Hello everyone, good evening. So Arvind here, your internal mentor. So I have joined in the before of the session so that we will discuss about your fourth project. So we'll wait for 5 more minutes so that others also can join. Then we'll start. Okay. Meanwhile, if you have any doubt, you just unmute yourself and you ask me.
So hi everyone. So this session we have Arvind with us from our internal tech team. So he'll be taking up some few project related stuff in the initial 15 to 20 minutes, and then he'll hand over the session to the mentor, and then your mainboard session will go up. Okay, Arvind, over to you.
Yeah, thank you, Rash. Thank you so much. Yes, Murli, your fourth project is Clickstream customer conversion. So I think it's been assigned to you guys on Monday, right? Yes. So there was no Tamil recorded session, sorry, English recorded session for this particular batch. So I thought of joining and giving you an overview about the project. Yeah. So how about the other projects? Third project and all got completed. Regression and all got completed from you people. Completed already. Okay. How about others? Okay, I don't think people will join here after. Okay, anyways, if they join, they can watch the recording session from the beginning. So let me share my screen and quickly give you an overview about what's the project about. Hope my screen is visible. So the first project which was given to you was regression. So this is the second project in machine learning. Okay, so here you will be going to do three different tasks. One is classification, binary classification. Second is again regression you will do. Okay, third is clustering. So in these three major tasks, you need to complete classification and clustering, that is mandatory, and regression is not much mandatory, but still if you want to try you can do it. Okay, so let me explain what is the problem statement about. So the data set is about it's an online purchase data set, not exactly what they have purchased, but based on the mouse hovering over data. Okay, like how many minutes did the customer stayed in the website, where did they click. Okay, this is the data about. Okay, for example, if you are using Amazon website, no, how much minutes that you have spent on a particular products page. Okay, so whether you have clicked the review or not, whether you have clicked the customer support or not, whether you have clicked specifications, detailed specifications or not, like that, data will be. So based on that data, whether the product has been purchased by the customer or not. So that is the classification that we are going to do. So this is your first task. So hope it is clear. So second thing is, you need to understand what is the customer network looks like. Okay, how the customer background looks like. So for that, you need to do some clustering analysis. Okay, you can use clustering algorithms, k-means clustering and you can find what type of customers are there and how many groups of them are there for this particular data set. Okay, so to be precise, this particular data set is about online pregnancy women clots data set. Okay, whether they have bought the purchase or not. So based on that, we need to do this task. Okay, so in the last project, you all might have used ML flow, right? The same ML flow again, you need to utilize it here. Okay, so other than that, mm, so you need to train the model using this train CSV. Okay, let me open and show what the data set looks like. Okay, see, so you will be having year column, month column, day, order quantity kind of. So your target column will be, wait a minute, why it is not moving? Okay, your target column will be this price to column. Okay, so just note it down. I also given in the data description also. Okay, price to is where you need to do the binary classification. One means it relates to, I think it got purchased. Okay, complete a purchase. Okay, they bought the product means that refers to one, and if they did not buy the product means that refers to two. Okay, so this is the column that you need to make a binary classification problem. So on the price column is where your regression tasks will work. Okay, so based on the product, whether how much the price will come. So it's a simple regression, but you don't need to mind much on developing the regression problem, but you should mainly work on classification problem. Okay, so and so this is about the data set. Okay, it's a very simple data set. Okay, but you can do many feature engineering from this. So main thing, you need to do many feature engineering in this particular project. Okay, so before we get into the data set explanation, so first you need to train the model, as I told you. Second, you need to test the model using the test data set. So in the previous project, we have given you the entire data set. You might have used train test split library and splitted the data set into training and testing data. Okay, but here completely you need to train the model using train.csv. That train.csv you can split it, and that splitted part you can use it for validation purpose. Okay, but here this test csv can only be used after the model got selected. So if suppose if you are running 5 different models, and random forest, let's say random forest classification has become the number one model. Okay, in terms of F1 score and the precision recall everything. Okay, so take that random forest, and you need to test you need to evaluate the model using this test data CSV. Okay, I hope it is clear. Okay, so for this you need to utilize one um, library called pipeline. Okay, hope you might have heard about it, or else I'll try to explain it very simply. So pipeline is a concept where something you are building one pipeline, stage one, stage two, stage three, stage four kind of. Let's say stage one, if you are handling missing values, you might have write the code in the class and objects. Okay, and you should save that in pipeline as a stage one. Okay, stage two, you should maybe outlier detection means outlier treatment means that is stage two. So stage three, you will be dividing the columns into numerical column and categorical column. So in the categorical column, you will again divide into nominal and ordinal columns. If it is nominal column, you will go for one hot encoding, and if it is ordinal column, you will go for label encoding, right? So these kind of steps you will uh, save it in the pipeline as a stage 1, stage 2, stage 3. Okay, next to stage 4 means model building. So like that you will do. Okay, let's consider as of now we have three stages. First stage is missing values, second stage is outliers, third stage is your encoding method. Okay, so this is the three stages. Okay, once the pipeline get created, if you put any related data set into this pipeline, it will automatically do the stage 1, stage 2, and stage 3, and it will give you the result. Okay, so that's how the pipeline will work. So why this will work in this project is, so train data, you will do all your experiments, you will do all the data cleaning part, data pre-processing, everything you will do, right? So once you do that, you have to save everything inside a pipeline. Okay, this train after training, so this testing test.csv is there. Now you just take this test.csv and you just put it into the pipeline, and it will do all the required process, and it will give you the processed data out. Okay, that data you can feed it in your model, and you can test your model. Clear? So in your last project you have used ML. So in this project especially you have to use pipeline. Okay, so learn about it. We have given reference documentation all here. Okay, so here you can get the documentation for SQL and pipeline. Okay, it's a very simple concept. If you go through it, you will be able to easily grasp it. Okay, fine. So data set description has been given it to you guys. So year, month, day, order, country. So session ID, page one, page two, kind of. Okay, see, one more catch here is most of the data will be in integers. Okay, but just because it is in the integer, it doesn't mean it's a numerical column. Okay, so some of them are categorical column. For example, see the color, the number column 9. So color is actually color of the product, which means it's a categorical data, but in reality in the data set, so color is in numbers. Okay, so since it in integers, don't treat it as a numerical column, just you have to treat it as a categorical column. So like that, many columns are there, just go through it. Okay, see location, even in the location model, everything is in the already they have encoded. Okay, but not in a proper format. So you need to understand whether the particular column is categorical or not, and if it is a categorical, whether it is ordered data or unordered data, you have to find out. Then you have to encode the data properly. So please be careful on this. Okay, fine. So this is about the data set. Okay, so when it comes to future engineering, you have to work on the future engineering part, since we have very less data here. Okay, almost like 12 data columns only we have. So try to work on future engineering. I'll tell you one good idea. So based on that, you can create your own, you can come up with your own idea, and you can create columns and work on that. Clear? So see here, there is a column called country, right? So in countries we have only country. So from country we can create a column called continent, right? So 7 continents we have, maybe UK, USA, Asia. Okay, like that you can Europe, like that you can split it up your countries into continents, and you can make a some more relationship between the data, right? So like that you can you have to do many number of feature engineering using this data, and try to understand what is the relationship between the data, and make the model understand it. Okay, so yeah, this is about thing. And you need to create a streamlit application again. So again, in the streamlit application, my classification model alone, if you do that, would be enough. But if you want to make, you can also make a regression part. Okay, so that streamlit application should be, you have to take the input from the user. Okay, and you have to make a prediction. So that's how it will be. As you were doing from the beginning, the simple streamlit application, if you make it, that would be more than enough for this project as well. Okay, so so I was very fast, but um, hope you all get it. If you have a doubt, just you can ask me. And from your batch, I can remember only Murali Krishna. So Murali Krishna is being connecting with me in the through queries and PDFs. So other than that, I don't remember any of you. No doubts. Okay, Darshini. I know Darshini as well. Abdul also, I think I have connected, right? Abdul connected and okay. Okay, hope some of you have started doing the project. So I just thought of giving an overview, just taking 15 to 20 minutes in the beginning. So if we don't have any doubt, then I'll just hand over it to Mr. Vipul sir.
Yes, thank you, Arvind.
Yeah, thank you, sir. Thank you, sir. Thank you so much, sir. I just want to have a small discussion with you, sir. So, what what type of project that we can give, sir? Whether we can give DL or NLP or computer vision, which one that you are going to cover it up in the upcoming weeks?
Upcoming week, is it?
Yeah, maybe the next project I'm referring to.
Uh, got it, got it. See, basically, we have not started deep learning yet. We
Mm-hmm.
are still about to start. Today, we are going to start. So, if we have some sort of challenging machine learning projects, we can give them.
Okay, sir.
I'll suggest to just hold for a week. Don't give any projects for deep learning because it will not be covered in by this week, no?
Okay, okay,
So next to next week we can give them.
okay.
Not
So one more machine learning that we can plan, right? That's what you are referring to.
right. Machine
What?
learning you can give any sort of projects.
Okay, okay, sir. Okay, yeah, got it.
Cool. All right.
Yeah, thank you, sir. Thank you so much. Thank you, team. All the best. I'll take care.
Yeah, no problem. Yes, hi everyone. Hi everyone. How are you guys doing? All right. All right. Okay. So what we'll be doing is, first of all, if you have any questions, you can ask. Otherwise, we'll just start with the next agenda. And by the way, what was the last topic that we have done, guys? What was the last part, guys? Yes, everyone. What was the last session? PCA. Oh, yes, I remember. Still, we have not finished yet, right? We were working on some data. PCA, is it done or not? PCA in Python 19 Jan. This is what we have done. Loss segregation plus PCA. Okay. Second is Yep. PCA is done, right, everyone? It's done. Yes, I remember. Do you have any questions in PCA? Anyone? Do you guys have any questions in PCA? Okay, we were working on some data, is it? This is completed, guys. Yeah, it's completed. Okay, let us go to the next agenda, next topic, which is going to be boosting. So we are going to start gradient boosting. We are going to start your extreme gradient boosting, XGBoost. We are going to see the, what we can say, mm, AdaBoost, right? Yeah. Just let me open this. Give me a minute. I'll just open this. Yes. Yep. 19 Jan. Yeah. This is your today's 25th. 2025. Yes. So let us start with the boosting concept. You guys already know about this, or rather, if you don't know, we'll start with this. Let's understand the notion of boosting and how does it works, right? So to begin with, we have a fair understanding of what bagging is. That is your random forest model. Everyone knows that. To give you guys a historical background about this, so it is one of the most powerful ideas introduced in the field of uh, or introduced in 1997 by, I'll not pronounce their name because it's very difficult. This one I can pronounce, Robert, but what about this Shafar, right? What they did is they introduced this model, and it was one of the popular machine learning model, that is AdaBoost. That is your AdaBoost. So AdaBoost, right? They have proposed this model. Since its inception, many other boosting algorithms that tackle regression problems have also been developed and have become well known as they are used to design top solutions of many Kaggle competitions. In this module, you will learn the concept of the most popular boosting algorithm known as AdaBoost, then gradient boosting, and then XGBoost, right? So in the previous course of tree models, you went through different ensemble methods. In this particular course or session, we are going to understand the ensemble model, that is boosting, right? So we are going to see AdaBoost, we are going to see gradient boosting, and we are going to see XGBoost, right? So in this session, you will be introduced to the following concept of ensemble methods, ensemble or ensemble methods, then introduction to boosting, and building blocks of boosting, and AdaBoost procedure, AdaBoost procedure, right? So let's start with this. So the very first thing is, first thing first is your ensemble method. What do you mean by that? Ensemble method. Yep. So before proceeding further, you should revisit the content on ensemble methods explained earlier. That is nothing but bagging and boosting. We already have discussed this. But this module will be focusing on, there are two ensemble methods. One is bagging, one is boosting. But in this session, we are going to focus more on what? More on your boosting method, right? So do you know this fact? Everyone knows this. Why I'm asking this? The strength of unity lies in the diversity, right? We often say this thing. What do you mean by this? This particular saying holds the same meaning in the world of machine learning. Ensemble models bring us flavor of diversity to create powerful models that can handle complex problems. And it is a combination of models, basically. Uh, it is a combination of model, each of which are trained to solve same problems and provide the best result at the end. For a machine learning task, let's say classification or regression, you need a model that identifies the necessary pattern in the data and does not overfit, right? Everyone need a model which uh, identifies a pattern and what we can say, does not overfit, right? In other words, the model should not be so simple as to not be able to identify even the important patterns in the present in the data, right? It should not be simple, right? On the other hand, model should not be so simple that it is not able to identify even the important patterns present in the data, right? On the other hand, on the other hand, they should not be so complex as to even learn the noise present in the data set, right? This solution can be arrived at either through a single model or the collection of models, right? That is an ensemble, right? An ensemble or ensemble learning create a strong learner, thus reducing a bias or variance of the individual model. So you can achieve this thing by using a single model or collections of models, but uh, but let's say by combining several models, that is ensemble, it create a strong learner, thus reducing the bias and or variance of the individual models, right? Then we have bagging with us. We have bagging with us. So it is one such ensemble model. It is one such ensemble model which creates different training subset from training data with replacement, right? So it is bootstrap aggregation. Everybody knows this. Then an algorithm with the same set of hyperparameters is built on these different subsets of data. In this way, the same algorithm with a similar set of hyperparameters is exposed to a different subset of uh, training data, and the resulting slight difference between the individual models, right? The prediction of these individual models are combined by taking, yeah, basically, you are going to create some different models, like this is your model number one, this is your model number two, right? With different subsets of data, basically, different subsets of training data, right? Different subset of training data. So this is your model 3, M1, M2, and M3. And it results in a slight difference between the individual models. So obviously, if this is different training subset, this is this different training subset, and this is the different training subset. So basically, what happens is it results in a slight difference between the individual models, right? So the predictions of these individual models are combined by taking, how do we get predictions? Predictions of these individual model are combined by taking the average of all the values for regression or a majority vote for a classification problem, right? So the random forest is an example of bagging. Example is random forest. You guys already have seen this, right? But bagging works well when the algorithm used to build our model has high variance, right? It works well only and only when the algorithm used to build our model has high variance, right? So this means that the model build changes a lot. The model build changes a lot, even with the slight changes, right? Even with the light changes, model build changes a lot, right? That's what we mean by high variance, right? So recall, if the decision trees are prone to overfitting, if the hyperparameters are not tuned well, bagging works well, very well for high variance models like decision trees, right? Now let us understand boosting. Everybody knows bagging. Let's go and shift our focus to boosting. What is boosting, guys? What do you mean by boosting? So it is another popular approach to ensemble, another popular approach to ensembling. This technique combines individual models into a strong learner, combines individual models into a strong learner by creating sequential models such that the final model has a higher accuracy than the individual models, right? Let's understand this by taking out an example, right? So what I'm doing is I'll draw one figure. So suppose this is my model. right? So this is my suppose initial data set. And then what happens is I have passed through some sort of, then again, uh, we kind of enhance this model, right? Again, it will give some sort of output. Again, enhancement is done for the another model. So likewise, the stepwise sequential enhancement is happening, and then you are going to get the final output. So basically, these are the base model, guys. 1, 2, 3. These are known as base model. What do you mean by base model? It's just a model. It's just a machine learning model which slightly gives higher accuracy than 50%, right? Slightly higher accuracy than 50%. So it's a random guess, better than a random guesser, right? So it can be any model. It can be your linear regression, logistic regression, anything. But it would be a model which slightly has higher accuracy than 50%, right? So I can write down over here the individual models. These individual models are connected in such a way that the subsequent models are dependent on errors of the previous model, and each subsequent model tries to correct the errors of the previous models, right? Individual models are connected in a such a way that the subsequent models are dependent on the errors of the previous model, and each subsequent model tries to connect what? Tries to correct the errors of previous model. So that's how it happens. Like you have a model, it is very base model, let's say 55% accuracy. It will be trained on its error. This is fed to another model. So this model number two, it will learn from the mistakes or errors that this model one is making, so that this model two will not make this error, right? Again, it will give some output. Again, it will be model 3 will be learned on the mistakes and the what we can say the errors that this two models are making. So it will improve that. So slightly accuracy will be improved, and we'll be achieving such position where there will be very low bias. So the final output is ensemble model with low bias than its components. Right? Final, the last output. It will be having a low bias than its component. Right? So these individual models are known as weak learner, guys. Right? This base models, random guesser, it is also known as weak learner. And this term is more widely used rather than this two term, right? All these terms are same only, nothing different in all these terms out there. But what happens is uh, it is more popularly known as weak learner, weak learner or learners, I can say, right? So let me maximize this to 15. Let me take this to this to this, right? Before proceeding further on boosting, let's make a look at the foundation of boosting algorithm, that is your weak learner, right? As discussed earlier, boosting is an approach where individual models are connected in such a way that they correct the mistakes made by the previous model. Individual models are connected in such a way that they correct the mistakes made by the previous models, right? And here, these individual models are called as weak learners. Here, individual models are called as weak learners. Simple, right? So till now, all the models you have learned are strong learners, where each model performs well on any task assigned that it is assigned to do, that is classification or regression, right? Weak learner, on the other hand, like till now, whatever models that you have learned, whatever model, random forest, XGBoost, sorry, not XGBoost, descent reel, SVM, logistic regression, they are they were strong learners, right? Where each model performs well on any task that it is assigned to do, right? Classification or regression, right? So a weak learner, on the other hand, what is weak learner? Refers to a simple model. As I told, right, it is a simple model which performs at least better than a random guesser. What is random guesser, guys? It's just a model. Basically, the error rate should be lesser than slightly 0.5, right? So I can say accuracy should be slightly greater than 0.5, just slightly greater than 0.5, right? So it primarily identifies only the prominent pattern present in the data, and thus it is not capable of overfitting. And in boosting, such a weak learners can be used to build your ensemble, right? Weak learner used. It is used to build an ensemble model. Now, uh, there is one more terminology, guys. It is known as decision stump. What is that decision stump? It's very simple, guys. See, I'll draw it over here for you, guys. This is my decision stump, only level 1 decision tree, right? So one such weak learner, when talking about the shallow decision tree, is known as decision stump. So what is decision stump? It is one such weak learner when talking about a shallow decision tree having a depth of only 1. Simple, right? Now to summarize this, what we have learned till now, weak learners are combined sequentially such that each subsequent models correct the mistakes of the previous model, resulting in a strong overall model that gives good prediction, right? Through weak learners, you can do the following. You can reduce the variance of the final model, making it more robust, that is generalizable. Or you can train the ensemble quickly, resulting in faster computation time. Right? So basically, a weak model or weak learner is not capable of overfitting. It has to be at least better than a random guesser, and any model can be a weak learner. So there's no any criteria of weak learner, guys. Only it should have accuracy greater than 0.5. So it can be linear regression. It can be your decision tree. It can be your logistic regression and so on. Right? Clear, everyone. And it has a depth of 1. It has a depth of 1. So now that you have understood the weak learners are, let's try to use that in AdaBoost. Now I'll take one example for AdaBoost. Let us try to take this AdaBoost. So what happens is, guys, let me check, do I have PPT for AdaBoost? Do I have this presentation? It's not there. AdaBoost. Don't we have that? Just a minute. Yep, this one is what I'm talking about. Yes. All right. See, what is happening now, guys, is how can I explain this? Just give me a minute. Just a minute. I'll just tell you one story for this. I need to check that. Story in form of example, basically. I want to take one example for this. Just a minute, guys. Let me take this. All right. Let's do this. So, yeah, what is happening is, can you see, suppose this is your data set. We have to classify plus and minus into different classes. That is our problem statement, right? So in the cases, higher points are assigned to data points which are misclassified. So this is my decision tree 1. And as it is a very weak learner, let's say it is not able to classify plus and minus. So it has put a decision boundary like this, right? So on the left hand side, you have plus, right hand side, you have minus class. But can you see, we have misclassification for these 3 points, right? They are supposed to be here, but due to some reason, as it is a weak learner, the error it is making is these 3 points. So it will assign maximum weightage for these 3 points, right? So you can see over here, the plus sign is big, right? For as compared to other thing, right? So as you know, this is important. So it should be like this now, right? Now, if you do this, the misclassified data are nothing but this data. Which one? This one, and this one. So you should give maximum weight to these three data points. So now the final box, final decision tree will be like this, right? So that's how it works. Now in this step, this data point is incorrectly classified. Only one data point is incorrectly classified. So you'll give maximum weight to that. Yes or no? So let's read this. Box one, you can see that we have assigned equal weights to each data point and applied to a decision term to classify them as plus or minus. The decision term has generated vertical line at the left side to classify the data points. We see that this vertical line has incorrectly predicted 3 plus as minus. In such case, we'll assign higher weights to this 3 plus and apply it to another decision term. Yes or no? Then after giving higher weightage, box 2 is here. Here you can see the size of 3 incorrectly predicted plus is bigger as compared to the rest of data points. In this case, the second decision term will try to predict them correctly. And now a vertical line D2 at right side of this box has classified 3 misclassified plus correctly. But again, it has caused misclassification errors. And this time with 3 minus, again, we'll assign higher weight to 3 minus and apply another decision term. Again, this same procedure will happen. Box 3 here. The 3 minus are given higher weightage. The decision boundary is this. Now this one, and this one is incorrectly classified. We'll assign higher weights to them. And like that, this procedure will carry out. And you can see that this algorithm has classified these observations quite well as compared to any of the individual weak learner, right? So it's kind of training weak learners, right? And if it fits a sequence of weak learners or different weight training data, it starts by predicting original data set and gives equal weight to each observation. So that's how it happens, and that's how it proceeds further. So mostly we use decision terms with AdaBoost, and we can use any sort of machine learning algorithms as a base learner. And if it accepts weight on the training data set, we can use AdaBoost algorithms for both the classification as well as regression problems. Simple. So that's what the idea is, right? So this is how your machine learning problems, or your uh, working of the AdaBoost happens, right? So I'll be sharing this presentation, don't worry. That's what we have for AdaBoost. Now it's time to summarize this. Okay, I'll write down in some points so that you can get a quick overview of what is happening over here. So on the surface level, AdaBoost is nothing but on the surface level, AdaBoost starts with a uniform distribution of weights over training examples. Okay. This weights tell the importance of the data point being considered. We first start with a weak learner, that is h1 of x, to create the initial prediction. Then patterns which are not captured by previous models become the goal for the next model by giving more weightage, and then the next model, that is weak learner, trains on this resampled data to create the next prediction. And at the end, we make a weighted sum of all the linear classifiers to make a strong classifier. Simple. That's how the things happen, right? Let's take a break now. If it is clear, if you don't have any questions, let us take a break. Yes, guys, is it clear? So now we are going to start some numerical example to understand this what we can say AdaBoost in more detailed fashion. Right? So the example that I'm going to take is of that glucose and non-diabetic and diabetic patient wala example, right? So I'll quickly write down heading and let's take a break for 10 to 12 minutes. I'm very exhausted today. Had 2, 3 classes. 15. So, yeah, and was busy with some other emergency as well. So from morning itself, I'm continuously doing some or other task. Anyway, it's 4:58. Let's have a break till 5:10 p.m. Right? 12 minutes ka break. Let's have this. Hello, guys. Just revise this, everyone. All right, guys. Let us start by taking an example of uh, the same thing that we had, which is nothing but we had data related to glucose, insulin, BMI, age, and whether a person has diabetes or not. So I'll be adding few values. Let's say 89, 94, 28.1, 21, -1, right? And let's say we have some data like this, tabular data, right? Now, this is our column. Now, the problem statement is we have to diagnostically predict whether or not patient has diabetes based on the given feature. Whether person has diabetes or not, right? So, to diagnostically predict whether a person has diabetes or not, so what we do is we assign sample weight, right? Initially, weights will be equal as we have seen in that diagram, right? Weights will be same across all the, you know, all the data points. Yes or no? Let's say all the weights are same. So what we are trying to say is, so initially weights are equal, no, for decision one. That is what it is. So initially weights are equal for, let's say, all the, you know, data sets or all the entries. 0 0.1, 0 0.1, and so on. So I'll be copying this and pasting it over here. Now, so ideally the formula for assigning weight is 1 divided by n, whether n represents the number of rows that you have. Suppose you have 10 rows, so it will be 1 by 10, and all the weights will be 0 0.1, 0 0.1, 0 0.1, 0 0.1, like that, right? So my step number 1 would be initialize. What I want to initialize? Example weights, I can say. So at the very beginning, each sample is associated with a weight that indicates how important it is with regards to the classification, right? With regards to classification. Then we have as AdaBoost. So here I have glucose. I have non-diabetic. I have diabetic, right? If the glucose is less than 127, let's say, and if it is greater than 127, so that will be my, you know, decision term with the depth of 1. What is decision term? It's a decision tree with the depth of 1, right? So you're assigning this step number 1, initializing the sample weights. Then what happens is, right after this is, you will take into consideration, let's say correct predictions are 5, incorrect is 1. Here also you have correct prediction as, let's say, you know, 3, and correct is, so incorrect is 2, right? Now, how do you find the variable which will become the root node for the decision tree? A revision question for you. How do you guys find the variable which will become the root node for the decision tree. How do you find that? How do you find that, guys? So the variable having highest Gini impurity, no? Gini score is chosen as the root wala node, root node. And this is Gini score, right? And what about Gini impurity? The variable which has lowest Gini impurity. Right? Gini score is information gain only. That is, if you remember the decrease in the weight, right? Suppose there are two guys, A and B, both are having 100 as their weight, right? At the end of this month or at the end of this year, this guy has reduced 30 kg, this guy has reduced only 20 kg, or let's say 15 kg. So what is good for us? Reduction 30 is good or reduction 15 is good? Reduction 30 is good. So that is your Gini impurity. That is your Gini score or information gain. That should be high, right? Reduction should be as high as possible, but your what we can say, the Gini impurity, it should be, as it is impurity, it should be as low as possible. Simple, nothing difficult in this, right? Then as the, you know, suppose this particular feature is incorrectly classified. This is incorrectly classified, let's say. This is incorrectly classified. Oh, sorry, not this color. It should be this, suppose. Now you are going to, as a part of step number 2, as part of your step number 2, you'll build a base model with each feature with the current observation. It's simple. So for each feature present in the data set, we build a decision tree, the depth of one, classify the data, right? That's what the idea is. Okay, then what happens is there is lots of mathematics associated with this. Let's not discuss that. So basically we start with the base model. I'll give you an example. We'll start with the base model. We'll give equal weightage to that, equal weights. And then we just observe incorrectly classified data, and that will be given higher weightage. That will be given higher weightage, so that when a new weak learner is trained, it will give more attentions to this misclassified observation. And in the end, you get a series of models. You get a series of models that have let's say different, say, according to the predictions of each weak model has made. And if the model performs poorly, and makes incorrect predictions, it is given less importance. It is given less importance. Whereas if the model performs well and makes correct predictions, if model performs well, makes correct prediction, it is given more weightage, right? And makes the correct prediction most of the time. So Whereas if model performs well and make correct prediction, most of the time it gives more importance to the overall model, more weightage. So that's how the idea is. That's how happens in all the boosting model out there. There is a lot of mathematics terms, as I told, error terms, error rate, yeah, alpha, beta. Let's not discuss that. And it is not important as well as far as your understanding is concerned. So ideally, what happens is there's always gonna be some error. How do we know when to stop adding models? Yeah, yeah. See, it's not like that. What happens is this process is continued for a lot of time, right? So basically, if you are taking, let's say, I was explaining that part only. I'll show a visualization of weights for, you know, AdaBoost. Just let me have that figure if it is available for me over widely on internet. Distribution of weights in AdaBoost. Is it available for us? Visualization. No, it's not available. Okay, let me take my other tool. This one. Just a minute. See, surface level, you should only give focus to surface level, but if you are curious, we should explain that. I mean, I should explain that. We should discuss that. Let's do one thing. I'll be sharing this thing with you so that you'll get an idea about the AdaBoost part, right? Okay. Let's do one thing. Let us discuss this. This is what I am talking about. See, whenever we start with a new model, all the samples of the dataset need to have equal distribution of the weight, that is 1 by n. And also, new learner should focus more on the samples which is incorrectly classified as the previous iteration. To handle both these bottlenecks, a new dataset will be created by randomly sampling the weighted observations. And basically, we create a new and empty dataset that is the same size as the original one. Then we take distribution of all the updated weights created by our first model, and you can see visualization of the weighted weights as below. New distribution is like this. So 6%, 6%, 6% to the this other models and 50% to the base different model, let's say. And then after doing this, it will be 0, 0 0.6, 0 0.12 like that, 7 like that. So distribution is changed like this, right? And you may observe that total number of sum is 1.04 instead of 1. For simplicity, these values are rounded off. To fill our new empty data set, this is how it happens. See, we select numbers between 0 and 1 at randomly, and the position where the random number falls determine which observation we place in our data set. Right? It's very complicated. Even we guys don't give focus to this problem or how does it work in the back end. But still, let's see. Due to the weights given to each observation, the new dataset will have a tendency to contain multiple copies of observation that were misclassified by the previous tree and may not contain all the observations which were correctly classified. After doing this, initial weights for each observation will be 1 by 1, 1 by n, and then we can continue the same process as we learned earlier to build the next week learner. And there will be high level of mathematics of this, and then you can have the final model is strong learner made by the weighted sum of all the individual weak learners, right? That's what it is. That's what the idea behind the AdaBoost is. And extreme gradient boosting is also, see, I'll tell you, people will only give focus to surface level of understanding of all these models out there. Nobody here or you guys, I'll not suggest you guys to go in deeper to that because this is your master's ka part, master's part. So AdaBoost, you should know, like it is a sequential uh, model which trains the, what you can say, weak model, weak learner, to convert it into strong learner. Sufficient, more than that. XGBoost is also very complicated. Let's not discuss that. It also has a lot of mathematics associated with it. If you guys really want to read that, I'll give you one article about XGBoost and it's working. Anyway, I do have my YouTube channel. I have uploaded that particular video with on that channel, which explains how this XGBoost work, right? So if you really want that, you can go to this and have a look at that, right? XGBoost theoretical intuition. I'll just share my video. XGBoost. It might be in this. Maybe, I'm not sure. No, not here. Okay. Yeah, this one. Just a 10-minute video, guys. You can just have a look at this to get a good understanding of how it works. Are you with data where years back then, 2 years back, I have added this. Anyway, let's see if we have any practical implementation of this part or not. Let me check a data set. So we are interested to see boosting that. Boosting, yeah. In that we have gradient boosting, XGBoost classification. Okay, let me give you guys a quick overview of this. Yeah, see what is happening now. Let's have a look at this classification problem statement for boosting. This is gradient boosting. The the advanced part of gradient boosting is AdaBoosting, and advanced part of gradient boosting is XGBoost, right? So we are importing NumPy pandas. We are importing necessary libraries. We are reading our data. Let us load in the data set, which we call attrition, and have a quick look at the first few rows. Then this is our data set is all about age, attrition, business travel, daily rate, department, distance from home, education, employee count, right? Then looking at a number, attrition is null, right? Then correlation of features, then feature engineering and categorical encoding. Then we are doing encoding for these columns. right? Then we're storing categorical data in the attrition categorical column. Okay. Then get dummies, right? We already have discussed this. Encoding. Then concatenating two data frames and all that together. Okay, you guys, if you want this, no, I'll share this with you. I have one important call. It will take 5 minutes. Please allow me to take that. I'm sharing this link. Just bookmark this. Whatever you want to learn, you can start learning from this. So it is added material for you. And just give me 5 minutes, guys, please. It's an important call I need to pick. So yes, guys. What we were discussing is we were discussing this one. Yeah. So that's how the we are basically mapping yes to one, no to zero, splitting our data into trend test, implementing machine learning models, GBM classifier, adding these parameters out there, fitting our model, doing predictions, and then last but not the least, what we are trying to understand is accuracy. So accuracy is 88%. And I'll just give you one hint. I understand you guys are good to go with the model fitting part. So that's the reason I'm not taking this particular um, part practically, not doing hands-on session. But just remember one thing, guys. This model, whatever model that you guys will be having, the boosting model will always be giving us the highest accuracy. So it will be 88%. I mean, basically, first five models in that Gboost, yes, AdaBoost, and XGBoost will always be highest performing model. So you take any data set out there, perform all the machine learning models that you have studied, you'll find that XGBoost is highest performing model, followed by AdaBoost and Gboost. There is no any doubt that XGBoost is top. All the times it will be top. Right? So these are the code that we have for our data. I think there's nothing advanced part that I mean we should not go with the advanced part of this. Anyway, it's not needed for your interviews and everything. Let us go to the what we can say extreme gradient boosting. Can I have this? Just a minute. Yeah. So I can say it is a extended version of what is XGBoost. Basically, it's an extended version of gradient boost. It is an extended version of gradient boost. Right? We have extreme gradient boosting with the XG boost. Right? Similar to it is similar to gradient boosting framework, but more efficient and advanced implementation of the gradient boosting algorithm. Right? It was first developed by जो भी है अभी I'm not taking name Tyne Key chain and become popular in solving the Higgs boson problem. And due to its robust accuracy, it has been widely used in all the hackathons and all the machine learning competitions widely. And it performs very well. Number one model will always be XGBoost. So robust accuracy, it has been widely used in machine learning competitions as well, right? So what are the added advantages of XGBoost, guys? What do you think? I'll just tell you. The key features of XGBoost are, or uh, I can say key features are, so it's a, let's say this is XGBoost. So it is a parallel computing trees pruning using that first approach. Then missing value handling. Right? And we have regularization. We have regularization. So that was the added advantages of XGBoost. Now we'll discuss that one by one. We'll discuss this one by one. So suppose let's summarize what uh, we have seen till now and have a recap of three different algorithms. Right? First is my boosting algorithm. What do you mean by this? The models are added sequentially to correct the errors made by previous models. And this sequence of weak learners will produce a strong learner, right? Then we have gradient boosting. What is that? In gradient boosting, what happens is newly added trees are trained to reduce the errors, that is loss function of earlier models. The performance of model is optimized by bringing down the loss function, not less function, the loss function. And we have extreme gradient boosting, that is XGBoost. What it does is it is an extension, of gradient boosting machines with parallel processing, better optimization, and regularization. Simple. So what is parallel computing? When you run XGBoost, by default it would use all the cores of your laptop, and machine learning enables its capacity to do parallel computation. That's what the can you just imagine this? When you just run your what we can say XGBoost model. Basically, why XGBoost are good? XGBoost so good. First one is parallel computing. When you run XGBoost, by default, it would use all the cores of your laptop slash machine, enabling its capacity to do parallel computation. Then we have tree pruning for using depth first approach. So your XGBoost uses max depth parameter as specified instead of criterion first and starts pruning trees backward. Then you have missing values. XGBoost is designed to handle missing values internally, and the missing values are treated in such a manner that in missing values, any trend in the missing values, if you have, if it exists, that or basically is captured by the model, right? And we have regularization with us. That is the biggest advantage of XGBoost is that it uses regularization in its objective function, which helps to controls the overfitting and simplicity of the model, leading to better performance, right? And due to parallel processing, that is speed and model performance, we can say that XGBoost, XG, that is gradient boosting, is on steroids, right? So that are some advantages of your XGBoost. Now I think we can go to the next part. Yes, yes. All right. Do you guys have any questions in this, everyone? Or is it not clear, or do you feel this was little advanced part? Yes, guys. Yes, Abdul, Arvind, Arivoli, Chandramohan, Darshini, Gopi. Yes, Maulya, Prasita, Sharmila, Thammi, Varun, Karthik, and Venu. Is it clear? Yeah. So if you just take the XGBoost classification, so to begin with this, first of all, there is no any XGBoost in sklearn, right? We don't have any XGBoost. It's a separate model you can consider. It is created by separate entity. So if you just not working, if you just go to XGBoost, you'll see that their official documentation is not by XGBoost, right? It is created by different entity itself, and you have to follow their guidelines. So it is not sklearn. Can you see this? It does not comes under this package. Does not comes under XGBoost, guys. So you have to first install that. How do you install that? You will simply write down pip install XGBoost. Nothing difficult. Simply write down XGBoost, pip install XGBoost, and it will be installed, and then you start working on this. So anywhere if you guys are using XGBoost, you have to, before importing, you try writing down this, you'll not be able to get. So you have to first install. You have to write down pip install XGBoost, and then start working on this. Everything will be same, nothing difficult. The steps that we have seen, handling missing values, doing encoding, right? Then storing categorical data, everything will be same. And then actually the model fitting part is also same. The object creation, model fitting, model prediction, and model evaluation. These four stages will also be same. Only thing is, instead of the model that you guys will be using, you guys were using earlier, random forest, decision tree, SVM, naive bias. Here we will be having XGB classifier, right? And then rest of the things will be same. Like you calculate the accuracy, then you'll do hyperparameter tuning by using random search, right? That's what the idea is. That's the reason I'm not taking this thing. It will take some time. Okay, so I think we are good to go to the next part, that is your deep learning, right? We can say that proudly the um, machine learning part is finished, right? Now we'll start with the deep learning part. But before that, let's have a quick 5-minute break. Deep learning is something which is going to be very, very important for your next journey. And here, I think today is session 31, or I'm not sure. Just a minute. Let's check. 31 or 34, right? This will require at least 5 to 6 sessions for ANN, then at least 5 to 6 sessions for CNN, and 4 sessions that's considered for RNN. So it becomes 4, 6, 10, 10 plus 6. 4 session. Let's take 4. 4, 4, 5. 13. And then we have LLM and that kind of thing, no? Generative AI. Here we can take entire 5 sessions. So 8, 5, 13, 5, 18, and 2. Somewhere around 22, 25 session will be requiring. So we are going with a good pace, no problem. All right. It's 5:59. Let's have a quick break till 6:05, and then we'll be having a quick introduction about deep learning, like why it is required and what is the idea behind this deep learning, right? So let's have a break. If you guys want to have your coffee, tea, you can have it, and then we'll be starting with the deep learning part. All right. So let us have a um, introduction about the agenda part, right? So let us divide this into two modules. First, module one will consist of introduction to neural networks, part one, and module two will consist of introduction to neural networks, part two, right? So I'll write down over here module two, intro to neural network, part two. Yeah. And then module four will be um, module three will be practical implementation, not practical, industry applications of CNN, CNN, industry application of that. Then module four will be convolution, convolutional neural networks. And I'm going to give you an assignment which will be somewhat complicated. That is, and then module six will be recurrent neural network, right? So that's what the whole module will be. Entire deep learning, I'm summarizing entire deep learning syllabus. Let's discuss what we are going to discuss in Introduction to Neural Networks Part 1. So we'll discussing structure of neural networks. And we'll be discussing feed forward in neural networks. Yeah. In structure of neural networks, we'll be understanding the analogy of already exist, is it? 25th Jan. Yeah, let's have introduction to neural networks. So here we are interested to understand the architecture of a neural networks, and we are going to see working principles as well of artificial neural network, and basically information flow. What will be your information flow in the feed forward networks, right? Let us start with that. So basically what happened is, back in 1960s, 1950s, uh, the scientist, or you can say mathematician, you can say computer scientist, they have thought that they created an artificial neural network which is inspired by human brain, right? They have created an idea about this. They have created perceptron. We'll see this. What is that? Uh, they have thought that the basic unit of brain is neuron. So what if we just create an artificial neural network, or basically neural network, which is perhaps your artificial because it is created by human being, but it should act like your somewhat it should act like your human brain, how it takes decision and how it processes, right? So that's what the thought process is. And so that's the reason it is known as neural network, right? We have human neural network. Everyone knows that, right? It's complex network of neurons, and that sends electric signals to each other with the help of brain to help the brain process information. So the smallest part of this is neurons, yes or no? In our brain, right? And there are some chemical connections associated with this, but it kind of looks like this, right? And it's way complex. We cannot imagine this how it works. Basically. It's very difficult or complex. So they also try to mimic this human brain. So they have created different neurons. They are giving output. These are the known as neuron, and this is output, right? What is this topology? What is this? Uh, what we can say infrastructure of this neural network? We are going to see that, but not now. So as the name suggests, artificial neural network. It is inspired by human brain, although it is not as powerful as the brain, but it is most powerful. We can say most powerful, most powerful um, learning models in the field of machine learning, right? So in the past few years, deep artificial neural networks have proven to perform surprisingly well on complex tasks such as speech recognition. Speech recognition. So basically, what do you mean by recognition? We convert speech into text, right? Or machine translation, or rather image and video classification. Such models are also commonly called as deep learning models, right? So let us begin our journey into deep learning with an introduction to artificial neural network. So, um, so I'll not be explaining this human architecture. That is not our task to understand how it works. We are not here for biology class, right? But to give you guys an idea, um, let's simplify the human brain analogy for neural networks. So we can say human brain analogy for neural networks, right? Let's take this. Let's put it as 15. And first is collection of simple devices working together, building neurons. Then we can have billions of neurons. Then that's what we have, right? It's a collection of simple devices working together, that is neurons. And basically we can have billions of neurons, right? So let us learn about the basic structure and understand how information travel through neurons, right? So we'll take this figure and we'll try to paste it over here. And in simple words, the biological neuron that you have, it receives signal through dendrites, which are either amplified or inhibited, And as they pass through the axon to the dendrites of other neuron, the information is amplified or inhibited, right? Now let us take a look at how an artificial neural network is similar to the human brain, right? To summarize this, main bottleneck in using neural network is the availability of abundant training data. Neural networks find applications across various domains such as images, videos, computer vision, text, and speech. And note that the words deep learning and neural networks are often used interchangeably, right? So deep learning and neural networks are nothing but the same phenomenon, often used interchangeably, right? And also, artificial neural networks are collections of many simple devices called as artificial neurons, right? So it's nothing but it's a analogous to your brain neural network. ANN is nothing but it's a collection of many simple devices called as artificial neurons, right? The network learns to conduct certain tasks, such as recognizing a cat by training the neurons to fire in a certain way, which gives a which gives a uh, or certain way when given a particular input such as cat. So if I show you a cat image, right? Whatever I have discussed, this thing will happen in your brain, and your brain will give signal that yes, it is cat, right? But whatever happens in the back end, we don't have any idea about that. But we have discussed this, how these things happen by taking help of axons, dendrites, and signal inhibitor and amplification process will be there, right? Now, also, the artificial neural network is a collection of artificial neuron, right? And many simple devices are called as artificial neurons. The network learns to conduct certain tasks, such as recognizing a cat. And in other words, networks learns to inhibit or amplify the input signals to perform a certain task, such as recognizing a cat, speaking a word, or identifying a tree. And in the next segment, you will be studying the basics of perceptron, a very basic model of artificial neural network, very, very basic model. So it is one of the earliest proposed, we can say, models for learning simple classification tasks, right? Which later became the fundamental building block of artificial neural networks. So what is perceptron, guys? See, I'll just draw one figure. Basics of perceptron we'll study, and then we'll stop here for the day. So the perceptron was, I can say, it was the first step towards First step towards what? Towards creating the large neural network. Why I said large, not large? Because it's quite large, right? It is very large. You'll see this in the upcoming session that have developed today. So it is first step towards creating large neural network that has developed today. Right? Let's take an example. Let us take an example to understand how a perceptron works. Very simple example, right? I'm not going to give you guys a mathematical form of that. Nothing special, nothing complicated. Very simple. So just consider, let's say, as most of you guys are South Indian, so let's not take South Indian food, but let's take some food which is not quite what we can say uh, easily available for us. Let's take consider a sushi place that you are planning to visit, right? So let's take one example of any restaurant. Mm, let's take mainland China, right? And you're planning to visit this Saturday or tomorrow. Let's say tomorrow everyone is having holiday, 26th Jan. So you guys are, you guys are planning to um, visit this shop, sushi place, to just have a sushi, right? So there are various factors that would affect the decision, right? Now, if you just search sushi place in Mumbai, and suppose you consider you are living somewhere around this place, let's say Andheri West, somewhere around this place. Let's say, just a minute. Now, how to take this? Just give me a minute. Sushi place in Mumbai. Yeah. If I just open map, and let's say you are living somewhere around this place. Let's say you're here, right? Vileparle. And you wanted to visit, you wanted to you wanted to go for this place, sushi, right? Now, if I just search sushi place, or it's already there, right? So this sushi, which is there in Juhu, or this is there in Koi, sorry, not Koi, I don't know this location, or Kofu, right? What will be the factors that will decide our decision? It will be, I'll write down over here, factors affecting um, decision, our decision basically. First place, you have to give the distance. You have to consider distance between the sushi place and your home, right? Second, you have to consider the cost of the food associated with it, right? Suppose if somewhere they serve there. Suppose if you have two restaurants or three restaurants, A is offering somewhere around 1,000 rupees, right? B is same cheese, B is offering for 500 rupees, and C is offering for, let's say, 200 or 250 rupees. Obviously, the quality will be different, but let's think realistically. We'll not be spending this much amount, 1,000 rupees, right? So cost will definitely affect. Then the number of people accompanying you will also be a matter of fact or to take up the decision, right? So you make such decision based on these multiple factors that we have taken over here. Yes or no, guys? Right? And also, each decision factor has its different weight, right? Though, so for some people, the distance is more important. So let's say 80% weight is given to this, what we can say, factor. 70% is given to this factor, cost, and number of people accompany is very less, let's say 0.2, right? So the decision factor that has a different weight, for example, distance of the place might be more important than number of people accompanying you, obviously, right? If you like sushi, which I personally like a lot, you will not be having any criteria of this, right? You will not be searching for someone who is with you to just have this, to just have your favorite food. Yes or no? So this will matter, the weight will be there, right? This perceptron works in a similar way. Similar manner, I can say. They take some signals as inputs. They perform a set of simple calculations to arrive at a decision. And let us try to understand perceptron diagram now in this in the remaining 4-5 minutes, right? So what I'm interested to do is I'll give you guys an idea about this perceptron. This is how it looks. It is developed by Rosenblatt, this guy. So this is your output. This is going to be your input. Simple. So there can be multiple inputs, 1, 2, 3, based on the conditions that you have, right? There can be multiple inputs. So each input has different weight associated with them, right? As we have discussed. So this is 1, this is 2, this is N or K or N, anything. So this is my input 1, X1. This is my input 1. This is my weight associated with that. This is my input 2, weight associated with that. So likewise, I will be having different weights. So it will be multiplication of x1 w1 plus x2 w2 plus so on and so forth plus xn wn plus bias, right? Plus bias. And that will be your output here. You will be having an output, right? So that's how your your perceptron will be there. So there will be a step function at the end of this output, before actually end of the output, which will trigger the, as you know, if you're taking something, if you're taking some decision, or if you want to drink water, your neuron will trigger, right? Your fire, it will fire, neuron will fire. Then only you'll make up decision of some activities, or let's say you want to have a call, you want to pick up call, or you want to drink water, or it can be anything, right? So it fires, right? So what does this step function does, guys? Mathematical step function, everybody knows that, but I'll make it clear for you. Suppose this is my step function and this is my axis. This is my axis, y-axis, and this is my x-axis, suppose, right? So for all the negative x-axis, all the negative x values, it will be negative, and all the positive, it will be basically positive. What we can say is, it ideally it will be either 0 or it will be 1. basically, right? So all the negative, it will be 0. All the positive, it will be whatever the positive value it will be. So if you just see a step function in mathematics, negative, it will be 0. And yeah, that increases or decreases abruptly from one constant value to another. A function that has constant value along given interval with a constant value varying between intervals. The name of this function comes from the fact that when you graph the function, it looks like a state of steps or stairs. So if you just try to plot this, it will be looking like this. This one. Right? So minimum value is 0, maximum is infinite. Minimum value is 0, maximum is, it can be negative, right? So at the end of this perceptron, you guys will be having the like the step function which will fire based on the given output or given input, right? So I can say the structure of a perceptron. I can say, if you just consider this diagram, just don't think anything over here. Yeah, this is something which is I can say w1 x1 plus w2 x2 plus so on. Let's say we have three weights, w3 x3 plus bias will be your input. And what is this thing, guys? What is this equation? We'll see that in the next session. Don't worry. So as of now, just we'll stop here for the day. In order to understand perceptron, we'll be having separate session for this, and we'll be continuing our discussion in for this module. Right? So, do you guys have any questions till now? Anyone? Right? We still have to see like what this perceptron is and how to create this mathematical function. We have not seen that, but we have seen the theoretical part of that, and I have given you guys an intuition about how the perceptron works, right? If you have some sort of questions, if you have anything to discuss, you can discuss. Otherwise, we'll stop here for the day, and then we'll see the next part in the on the next Saturday itself, right? Chalo. Anybody have any questions, any doubts? Yes, guys, please discuss. Yes, Abdul, Chandramohan, Arvind, Darshini, Gopi, Karthik, Maulya, Murali, Prasita, Sharmila, Tammi, Thangamani, Varun, Karthik. Anybody have any questions? Or if it is clear, you can write down in the chat. All right, I have got multiple response. Okay, then we'll stop here. Thank you, everyone. Happy learning. Bye.